I've had this drum machine under my bench for over 10 years. It was given to me by a client as partial payment for some other repair I was doing, and it was broken when I received it. And all I can remember is it just malfunctioned. I don't really remember what was wrong with it. And it's been sitting under my bench since then, waiting for me to repair it. So normally with something this old, before I turn on the power, I would take it apart and check out the power supply. But I'm going to throw caution into the wind and just turn this drum machine on and see what happens. So here we go. And so I can see some LEDs lit up. I'll pick one of the patterns and then press start. Okay, I can hear something. It's not what I'm expecting. What I'm expecting is to hear a prepackaged drum pattern. But all I'm hearing in each of this, when I push the selector switches down, is just one particular sound over and over again, or a few sounds at the same time. So let me explain what I'm doing. On the front here, there are 10 push button switches. The 8 on the right correspond to preset patterns for slow rock, swing, bossa nova, begin, rumba, mambo, samba, and waltz. On the left, there's a single switch, and it corresponds to 4 sub patterns. So this is the rock switch, and there's a rotary knob, and you can select between 4 different rock patterns. This is not what it's supposed to sound like, but and this switch here allows you to choose between tango, polka, foxtrot, and march. You know what? It sounds like it's stuck on the first beat of the pattern, because I know the rock patterns are supposed to start with a snare or a kick, and it kind of sounds like that over and over. Yet if I pick one of the Latin patterns, I can hear a clave or something over and over again. So it sounds like it's stuck on the first beat of each of the patterns. Let me just go through all the functionality. So the tempo sounds like it's working. This is the change and break section. I'll test that. If I hit this button, it will stop the current pattern, and it will play a little solo, a few bars of some sort of a break, do, 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 or something, and then go back to the original pattern. So let me just let's try that again. So it changes. It's not playing what I'm expecting, but it does change. Oh, and there's something else I noticed here. These 2 LEDs correspond with 2 variations for each pattern. So there's a variation A, which is the standard pattern, and then there's a variation B, which is usually a little more complicated sounding with more hi-hats or something. And the way it's set up right now is every time you insert a break or a change, after it plays the break, it goes back to the pattern, but then it goes to the other variation. So we're on variation A, and now a variation B, back to variation A, and back and forth. So that's working. Let me try the fade in and fade out. So this switch chooses between a long and a short fade, and if I hit the button, we should hear things fade out. So I'll choose long and I'll hit fade out. Yeah, and it sounds like it's slowly fading out. Okay, so that works. If I hit the button again, it should fade in. There we go. I'll try short, so this should be a little faster. Yep. A little bit of a faster fade out and fade back in. Balance control. So how the balance works, it's just a tone control actually. So on the left, it accentuates the low frequencies like the kick and toms, and to the right, it accentuates all the high frequencies. So like the sizzle on the snare and, you know, the cymbals and claps and that sort of thing. The start-stop switch is a bit flaky. Okay, so it kind of works. So it seems like it's stuck on the first beat of each pattern, no matter what pattern you pick. The change break section seems to work, but it seems to just play one sound over and over again. Tempo works, fade in and out works, the balance is fine. Just stop, stir. Oh, it's working now, but it's a bit flaky. Everything probably needs a bit of a cleanup. Okay, so the main thing is to figure out why it's just playing the first beat of the pattern over and over again. So at this point, I will take things apart, and I'll go through the components on the inside and explain how everything works, and then I'll check all the clock signals, the counters, and that sort of thing to try to figure out what the issue is. Down here near the bottom where this big capacitor is, this is the power supply section. You can't tell from this view, but there's a power supply transformer underneath here that's taking the aligned voltage. And there's also a small daughter board here that has the 12-volt voltage regulator. So this power supply circuit will create plus 12, plus 5, and minus 5 volt voltage lines that go off to the various other sections on the circuit board to drive all the chips and components. The main chip here on the top, this white chip, this is a ROM chip, a memory, but it doesn't have samples in it like you might expect. It has bit patterns in it that correspond to each of the preset rhythms. For each beat in each of the rhythms, there'll be a 1 in the memory, which means a particular instrument sounds on that beat, or there will be a 0, which means there's a rest for that particular sound. And below the ROM chip, there are 2 counter chips, and they count up through the memory locations so that the ROM chip cycles through each of the beats in the patterns. Each one of these is a 4-bit counter, which means it can count from 1 to 16 or 0 to 15 if you prefer. So, and that totally makes sense both binary-wise, and also in this machine, the patterns are either 16 or 32 beats long. So that also makes sense. So they give the address lines into the ROM, cycling through all of the address locations. And then the output, the data lines, which come out on the other side of the ROM, go into this diode matrix and then down into this other section of the board here, which is the analog electronics. And there's a section of the board for each of the sounds. So there's a snare and cymbals and the kick drum. So when the line from, say, the snare output comes down into the snare circuit, when that line goes high, the snare drum sounds, etc., for all the other instruments. Up here at the very top, there's an electromechanical arrangement of switches. This is that row of 10 switches that select the presets. Some of the switches tie into the data lines in the ROM. So when you push a particular switch, it actually selects a different bank of memory locations in the ROM, and each bank of memory locations corresponds to one of the presets. But my main focus is trying to figure out why it's stuck on the first beat. So the first thing I'm going to do is turn on the power and check all the voltages and to make sure that at least the power supply and all the voltages that I'm expecting are making it to the circuits. Kind of figure out how everything is laid out here. So this should be a 12 volt supply, and I can see it's pretty close to 12 volts. This should be 5 if I'm not mistaken. So that's probably mostly for the digital stuff. The 12 volts is usually for the analog stuff, but not necessarily. And then there's a Zener diode here, and there's a -5 supply as well. And that's pretty close. Okay, so now that I know that the power supply is outputting the right voltages, I'm going to go up and check each of the chips. So I'll check the counter chip, so I happen to know which pin is the power. It's usually the same one on most chips. So this is getting 12 volts. Now, you may think it should be 5 volts for a digital counter chip, but this is, I believe this is an older CMOS chip, so 12 volts is kind of normal. Let me check the other one. Okay, so the counter chips are at least getting the right voltage. Let's try the ROM. So the ROM gets, this is an old ROM, so it gets plus 12 and also plus and minus 5 volts because it's an older technology. So there's the 12. So it's getting the plus 12. It's getting the 5. And this pin here is the negative. Let's try this again. Come on. A minute, let me check this again. So there's the negative 5 volt source. But it is not making it up to this ROM. Okay, 1 minute. Let me try following it. So there's, oh boy. Okay, I just noticed something. The -5 power supply line is the trace here. I can see it's corroded. I'll zoom in. I can see it's corroded, and on below the corrosion, I can see the -5. But if I go follow the trace all the way up to this other pad, yeah, it's nothing. Okay, so I think that's definitely at least one of the problems. So let me zoom in on that corrosion. I'm doing a little handheld here so I can get nice and close. So this is the Zener diode that regulates the -5 supply. So that point there should be -5, and there's a pad, and then there's a trace. You can barely see it here, but you notice all of a sudden it's green. That's the corrosion. So that trace then goes underneath this capacitor, and then the corrosion goes away. I'm wondering what's happening right there. And the corrosion disappears, and then you have the trace, and it comes up to this other pad, and then the -5 line then underneath the circuit board then goes to the ROM chip. So the problem is, or one of the problems at least, is this corrosion. So there's no connectivity on the trace here where you've got this green corrosion. So I think what I might do just temporarily is jumper between that pad and this other pad up here, just to temporarily give conductivity between those two pads to see if the behavior of the machine changes. I just grabbed an alligator clip lead, and I'm going to very gingerly jumper between those two pads, essentially jumping over the corroded section. And I'll very gingerly flip everything back around. Okay, I'll plug things in, and let's see what we get. Okay, we'll go back to rock 1. Okay, sounds like we're okay. It's bossa nova, rumba. Okay. Well, it looks like, let's try some rock 2. Oh, that's pretty funky. Let's try. Oh yeah, this is kind of neat. Okay, let's do the auto change thing. So I'll put it in auto change 4 beats or 4 measures. And there's the break back to the A variation. So it looks like that one trace, that one corroded trace, was the whole problem. So this is cool. It's going back and forth. We should get the break. And back to the A variation of the rhythm. So that seems like it was probably it. Okay, you know what I'm going to do at this point? This is so cool. I'm going to fix that trace, and then I'm going to clean all of the switches and all the potentiometers and clean everything up and put it back together and then run it through its paces again, because I think that trace was probably the only issue, because everything seems to be working fine. Hold on one moment. Before I do any of the repairs, I still have to check the main clock output and also the trigger signals coming out of the ROM circuit down into the analog drum circuits. So I set up my oscilloscope with 4 probes. This probe down here at the bottom takes the master clock output, and these 3 probes up here at the ROM are connected to the bass drum, snare drum, and hi-hat outputs. I'll start the drum machine, and you can see the signals coming through on the scope. So the yellow trace at the top is the master clock signal. The light blue trace underneath that is the hi-hat trigger. The purple trace underneath that is the snare drum trigger. And the dark blue trace at the bottom here is the bass drum trigger, or the kick trigger. The first thing you notice is everything looks uniform. I don't see any noise. I don't see any extra triggers, extra signals. The scaling here, maybe you can make it out. The scaling is set up so that each one of these segments is equal to 5 volts. So this shows that all of the trigger signals are 5 volts peak, and everything looks uniform. It looks fine. So let's look at each of the signals in turn. So the clock, as we said, looks uniform and fine. The pattern you're hearing is the Rock 1 pattern, and if you look in the owner's manual, you'll see that everything except one of the beats in this pattern land on the 8th note. So the hi-hats here are on even 8th notes, and if you listen to the pattern and watch them come in here, the trigger signals come in here on the right-hand side of the screen, you can see that they in fact come in on the 8th note. So that looks fine. The snare drum, the purple line, except for this one extra backbeat hit, everything comes in on the beat 2 and beat 4. So there's 2 and 4, 2, 4, 2. So this looks fine, and now you're going to see the extra backbeat, and that's on the 16th note boundary, and we'll look at that in detail in a moment. And the kick, or the bass drum, is pretty simple. There's a double kick on all the beats, except at the end, right before the backbeat on the snare, there's a triple kick. And these are on the 8th note boundaries. And they line up with the hi-hats, which we also know are even 8th notes, so that looks fine. So one thing we can use this trace to figure out is how many pulses per quarter note this drum machine runs at. You may know that with most analog drum machines, the internal clock is usually 24 pulses per quarter note. And if we knew how many pulses per quarter note this ran at, you could potentially modify it to synchronize it with other equipment, or even maybe do a MIDI retrofit so that you could sync this to MIDI clock. One way we can figure that out is to look at the hi-hats again. So we know those are on even 8th notes. Now I'm going to pause the oscilloscope once I get that snare backbeat. There is the backbeat. Once it's in the middle of the screen, I'm going to pause the oscilloscope. There we go. And I'll turn on the cursor so you can see what I'm doing. So I'm moving the dotted line, that vertical dotted line, and I'll line it up exactly with one of the hi-hat triggers. So that's this one right here. And then I'll move the cursor along until I get to the next hi-hat trigger. And I know that's 1/8 note, and I can just count how many clock signals I go by. So I'm going to go to the right. So that's the first clock signal I go by, so that's 1. And when I get to the second hi-hat trigger, I'm at the second clock signal. So then that tells me that there are 2 clock pulses per 1/8 note, because the hi-hats are on even 1/8 notes. So if there's 2 clocks per 1/8 note, and I double that to get quarter notes, I know there are 4 clock signals per quarter note. And I can confirm that with this backbeat snare hit, because I know that's on the 16th note boundary. So if I line up, sure, I'll do that again. If I line up the cursor with the backbeat note, which is this one here, I know that's on the 16th note boundary, and then I just advance to the next 8th note boundary, which the hi-hats provide us, and I'll just count how many clock signals I pass, and I get 1. So to go from the 16th note boundary back to the 8th note boundary, I only pass 1 clock signal. So then I know there is 1 clock signal per 16th note, and if I multiply that by 4 to get quarter notes, because there are 4 16th notes in a quarter note, again we get 4 pulses per quarter. So we know that this drum machine runs at 4 pulses per quarter note. So let me turn the cursor off and I'll start the oscilloscope running again. So this looks fine. Now ready to go on with the rest of the repairs. I'll narrate here in the background as you watch me do the repairs. So first, I'm just lifting up the circuit board to make sure there's no corrosion on the back. And it was clear, so that was okay. And now I'm just removing those 2 capacitors that were blocking the corroded trace. This is just to give me some extra room on the circuit board to do some work. And now I'm scraping away the corrosion, and this took a lot longer than what I'm showing here on the video. Now I'm cleaning up the mess with some Kim wipes and isopropyl alcohol. Kim wipes aren't just regular tissues, they're used for electronics and other delicate work because they don't fall apart or leave lint. Now I'm just measuring and cutting jumper wire to go between those 2 pads to bridge over where the corrosion was. Safety first. Now I'm just soldering it in place, and this is the result. And now I'm just soldering those caps back in. And now it's time to clean the rotary switches and the potentiometers with deoxit. And now I'm removing all the knobs to get access to the front panel. Here I'm removing the dust barriers on the switches, and you may notice that one of them is missing, but I'll get back to that in a moment. And now there's just a lot of cleaning. It's amazing how much crud can get inside a piece of electronic equipment. Here I'm cutting out a new dust barrier for the switch that was missing one. And I have to punch a hole in the middle so it can fit over the switch, and I just cut a little bit away so it will fit beside the LEDs. Here's more cleaning of the front panel, and now cleaning all the knobs. While I was cleaning the knobs, I noticed a lot of the chrome surrounds on the knobs. They were loose, So here I'm just gluing them back in place. Now is a good time to vacuum out the case. And while I was doing that, I noticed that some of the Tolex had lifted up. So I'm just gluing it back down. And now I'm just weighting down that repair and leaving it for about half an hour to dry. And now putting the other dust barriers back in place, and then the front panel. And here I'm putting all the knobs back in place and making sure that the indicator lines on the knobs match up with the panel graphics. And I'm also making sure that all the knobs and switches move freely. And now I'm just putting everything back into the case. So now all I have to do is screw everything back together. If you're wondering about all those bags with the numbered cards in them, that's how I keep track of the order of taking all the screws out when I take things apart, so that I just reverse the order when I put things back together, and I never have any missing pieces this way. Everything's put back together, and the SR-120 sounds great. That's it for this video. Thanks for watching.